All right, and now we have an exciting lesson about solving linear equations with a single variable. So Abigail, do you have any questions about that?
What's linear equation?
Okay, well, linear means that the equation involves only like a variable without any powers. So there's no like square or cube here. And then it involves some constants as well. So let's say we have 3 plus 4x equals 5. This is a linear equation because there's no powers of the x, like we don't have an x squared here, or an x cubed or anything, and we don't divide by x or anything. It's just something multiplied by x and then constants. That's a linear equation. And single variable means that we only have one variable, and then we want to try to solve this equation, figure out what x is. So let's start with an easier example, actually. So let's say we have the equation 4x, that means 4 times x, remember, equals 20. Now the way to solve this, one way to solve this is try to think of a value of x that would make this equation true. So Abigail, with that method, what would your guess for x be?
5.
5, that's right, because 4 times 5 is 20. So we know the answer is going to be x equals 5. But when the equations get more difficult, you can't just rely on the guessing method. So there's a systematic way to do it. And in this case, what you do is you divide both sides of the equation by what, Abigail?
4.
4, that's right. So I divide this side by 4, and I divide that side by 4. And what the interesting thing is that you're allowed, if you have an equation, that means two sides are equal. If you do the same thing to both sides of the equation, guess what? They're still equal, aren't they? So if I divide both sides of this equation by 4, what happens to the 4? It goes away. And I end up on the left side with an x, which is kind of what I wanted. And on the right side, 20 divided by 4 is 5. So x equals 5 is the right answer. So you're allowed to do the same thing to both sides of the equation. And what you want to end up with is the variable on one side and a number on the other, and then you know that that variable equals that number. Does that make sense, Abigail?
Yes.
All right, great. So let's try a second example here. This one's not too bad either. We've got 25 equals 5 plus y. And we want to figure out what y is. So, of course, we could guess what y is, but we're going to use the systematic method. So, Abigail, what should I do to both sides in order to get the variable alone on one side? What should I do?
Divide by 5.
Divide by 5. Okay. So let's see if that works. If I divide this side by 5 and divide that by 5. Well, there's actually a problem here. Because if you take 5 plus y and divide by 5, you're really supposed to divide the 5 by 5 and the y by 5. And I'm going to end up with 1 plus y divided by 5. So, let's not do that, actually. Do you have another idea, Abigail?
Yeah.
Okay.
You subtract 5.
Subtract 5. Very good. Okay. So, minus 5 over here and minus 5. So, 5 plus y minus 5 is just y. So, we have y on that side, and then 25 minus 5 is 20. So, y equals 20, and that's the answer there. Okay, good. Let's do another example here. Suppose we have m minus 9 equals negative 13. This is pretty much the same, it's just that we have some negatives here for tricky. So Abigail, what would you do to both sides here?
I would
What do I want to have? I want to have m all by itself, right?
Yeah.
So this negative 9 is in the way. So what do I do to get rid of that negative 9?
add 9.
Add 9 to both sides, right? Whatever you do to one side, you got to do to the other. Right, Liam? You got to... Well, I already told Liam he's not allowed to talk, but you're allowed to answer my question. So if you do something to one side, you got to do it to the other, right?
Mm-hmm.
If it's an equation. So let's see. What we get here is m minus 9 plus 9 is just m. And on the right, negative 13 plus 9 is just negative 4. So that's the answer. M equals negative 4. And for checking purposes, we can go back up to the top and say, okay, what if I plug in negative 4 for m? Then I get negative 4 minus 9. Does that really equal negative 13? Well, of course it does, because math works. All right, let's go on to the next one. So we have p minus 6 equals negative 5. So again, the thing to do in this case is to add 6 to both sides. Okay? And then on the left I've got a p, and on the right I've got a positive 1. So p equals positive 1. Great. Now let's go on to a harder one. Here, this next one involves multiple steps. You can't just do one thing to both sides. So let's say we have 8x minus 2, and that is equal to negative 9 plus 7x. Now here, notice a couple of things. First of all, we've got x's on both sides, and we've got numbers on both sides. So I can't just do one thing and have all the x's be on one side and the numbers on the other. So Abigail, what would you do first? First of all, do you want to get the x's onto the left or the right in this case?
Left.
Okay, well, it's really a choice, but let's try to get the x's all on the left. So what's one thing I could do to help in that problem?
You could add 2 to both sides.
Okay, great. I could add 2 to both sides because by doing that, I'm basically moving this negative 2 over to the other side and it becomes a positive 2. So anyway, let's just rewrite that. So I end up with 8x. The negative 2 plus 2 goes away. And I end up on the right side with negative 7 plus 7x because, you know, negative 9 plus 2 is negative 7. All right, now I still don't have my answer. So what's the next step, Abigail? What would you do next?
I would either subtract or divide by 7.
7x. Okay, that's a good question because we got to kind of figure out what's the best thing to do. We want to get this 7x away, right, so that we have only x's on the left. But the question is, do we subtract it off or do we divide off by the 7? Well, if I divide by 7, first of all, I've got to do divide by 7 on both of these things. And secondly, I'm still going to have an x there, right, if I divide by 7. So if I really want to completely get rid of the x, I better subtract off the 7x. Okay? So I'm glad we're learning something here. So it turns out that you have 8x minus 7x, which is, Abigail, on the left? 1x, which is just x, yep. And then on the right, I just have negative 7. So we're actually done here because we see that x is negative 7. Let's see if that works. Go back up here. 8 times negative 7 is negative 56 minus 2. The question is, does that equal, that's a question mark by the way, does that equal negative 9 plus, what's 7 times negative 7? Negative 49. Let's see, negative 49 minus 9 is negative 58. Yes, it does work! Hooray, because math always works if you do it right. All right, well, let's see. I think I'm running out of time for this lesson, so let me make a part 2. Okay, so I'll see you in part 2. Goodbye.